Transform your startup journey with the EnergyTech Nexus. Connect with fellow founders, access critical resources, and be part of a community shaping the future of energy and carbon tech. Your path to building a Thunder Lizard starts here. Learn more at energytechnexus.com.
Welcome back to the show. It's been a while, Jason.
Yes, it has.
But we are back. And today we're really excited to have a really special guest with us today. We have Mehrab Momin, who is your startup's fractional AI CTO. So he helps a lot of startups with AI and has lots of experience working with startups. So he had two of his own startups that he founded and worked on technology startups. And then he's worked with many other startups himself in Houston, also spent some time in San Diego, you mentioned. So thank you for coming and being here with us today.
Thank you. Thank you for having me.
So tell us a little bit about how you got to this role of starting your company where you act as a fractional AI CTO for startups.
Yeah. So as you mentioned, I've worked with multiple startups, being a founder myself. And actually I also did bit a service provider before. So between that, I felt this gap where especially early stage founders, both technical and non-technical, sometimes really need this partner, which generally in a startup world we call co-founders, but they are not ready to have that co-founder level relationship, either because of resources or they don't know if it's the right person. And on the service side, I always worked with project-based work, which felt very, very transactional. I really needed something which is much more engaging, where I can give that partner level advice to the founders. So basically, I am that co-founder for hire, which you don't have to make long-term commitment. And also, there are no drama, and eventually you can do transition out, which I help them to get to a full-time CTO as and when that need arise. And so basically, I felt that was important. So that's just one aspect of it. The second aspect was I had been working with AI for a long time. So I didn't want to build just any product. But at the same time, AI on its own is not going to do the thing. You have to build a full application around it. So I had that experience, had AI experience. I said, how do I package it together and do all of this together? And that combined to make this new role, which I created for myself, that let's build a fractional AI CTO practice. I'm slightly ADHD, which helps. That way I'm actually working on with multiple people on multiple things. So that helps as well in the fractional role.
And you happen to stumble onto AI quite early on in your career. So talk to us about that journey and, from where you started and where we are today, where AI is all everyone wants to talk about.
All right. Yeah. So actually AI is pretty old, right? So it's started in the initial neural network started in 1950s. So very, very old. So in my college in final year 1996, I did my first AI project and it went nowhere. It worked, but it was not practical because processing power was not there. But in 2005, I was working for this company, Air Liquide, and they had some researchers from Boston who form a company around something called swarm intelligence. And that allows you to do a supply chain and scheduling kind of optimization through AI. And it's all built on nature. And I end up working on that project. Lots of things I did around that project is now called data engineering, data pipelining, MLOps. None of these terminologies exist. I didn't know how big deal it was until in 2007, National Geographic did an article on swarm intelligence. And our project was one of the projects they use as an example where my manager got interviewed. And I was like, okay, I was working on something cutting edge. So it's an interesting topic, but that was very, very early. And then later on, I actually worked on my own startup on computer vision. This links back to my college days. And build an AI camera, computer vision AI camera. Had a patent around it as well. We were too early in some of the technology, but it was a good experience.
Can you, I think a lot of our audience, we're kind of energy heavy. We probably know about technology. I think AI kind of gets bandied about a lot for a lot of different technologies. And I'm sure when you started your career, it meant one thing. Swarm intelligence is a different thing. Can you kind of take us through kind of what the different flavors of AI are and how that's different today with Gen AI?
Yeah, so I think that's the history of AI is actually how the energy industry has been adopting it for a long time as well, and many others. So early AI was much more simpler, where you started having simple like models, statistical models, and that's where most of the machine learning models started coming in. And I think some of these was restrained by the development in AI itself, but later on you had deep learning model because you could have deep neural networks started developing.
And what does that mean when you say deep neural network versus a statistical model?
Yeah, so machine learning model, statistical model, because most of this AI is still based on statistics, but you are doing different statistical formula on your machine learning model, and then there is the next thing which came up is neural network. So within those neuron, that is artificial neuron, is where you still use a statistical formula to process it, but then you form a node. And that neural network itself is a game changer on how that the entire machine learning process works. So for machine learning, lots of your statistical models you're building are much more human driven than what model will look like. In neural network, then you are actually relying on the kind of self-learning model that is getting developed. And then when it goes much more deeper, when computer vision on these kind of you add many layers to it, that becomes a deep neural network. So even the Gen AI today is a form and a interesting architecture on top of it. So there's more things get added. So at the journey I'm talking to you about this ML models to deep learning model practically got used in industries in last 20-25 years, even though there are other neural networks and other things were getting used. But in 2014, then there's this new paper was written by Google, Attention is What You Need. I think 2014 or 17. Sorry, I may be missing the date, but because there was some embedding models came in earlier, which were also basis. So maybe that was 2014 and 2017 was Attention. And then based on that Attention is All You Need. That's an architectural change within the model that allowed for natural language processing. So which allows the meaning in the language to actually got translated in or codified in a math, which allowed this model to develop. And that became the basis for Gen AI. So that's the journey that people went through.
Interesting. So it's a lot of layers. So in some ways, I think talk about AI applications, and it's a lot of the same underlying technology, but like the form or the application really matters. Right?
Yeah. So I think the way I would describe it is building blocks. Each of these are different building blocks, and they got configured in differently. And that gave a new type of building blocks got introduced within that, and that is how we are evolving on it.
Interesting.
Yeah, I think that's interesting because I think you go everywhere today and everyone's talking about AI, but what they're really only talking about are like the natural processing models, the LLMs, the ChatGPTs that people are actually using on a daily basis. But there's like so much at the back of it, and there's so much more to AI than just those ChatGPT chat boxes that we use, right? And that we can build on to make automated workflows. And we're talking about agentic AI right now. And like machine learning in industrial context have had also a great impact. What have you seen kind of how different types of these building blocks have been applied in different industries?
So the way actually there is it's as I said, it's like history of AI itself. So earlier part, I didn't mention there was another startup I work on, file control. We used OCR. This is back in 2000 to 2002 time frame. And OCR was a very early computer vision, natural language kind of model, right? So that's early, like people started doing that. And then the one I mentioned about swarm intelligence was a neural network. It has a very specific way of configuring things to work. But so machine learning started coming in. And I think back in, it's like a 2010s and around those time, Google created certain libraries which actually really accelerated the use in of machine learning in the model. And most of the machine learning model initially came from tabular data. So that was happening. At the same time, natural language processing was also happening. And you may have seen some Google Translate and another type of OCR or some language understanding, but it was not very good. And I think that 2014 timeframe, when I said embedding models started coming in, suddenly this whole your Google Translate, if you started translating much better. So that was the evolution on the natural language side. And same way those ML models started becoming like better as well. Actually, I want to just clarify that ML models and deep learning models, it kind of interchangeably used a whole lot of time. I differentiate it like that, even though there is a definition in the industry. So somebody may even call a deep learning model as an ML model. Nothing wrong. I think once you are actually implementing it, the devil is in the details. So I just want to make sure that I clarify. People may refer to it slightly differently as well. But for me, anything which is statistical based models are ML models. Anything with neural network based model or deep learning models.
Okay, interesting. Yeah, and like you're saying, because they're used interchangeably, like people have different schemas that they use on like what is ML for them and what is natural language processing.
It's still machine learning. Like even your LLM is a machine learning. If you're even going to use it just a natural language, but there is an industry term and syntax. If you talk to any ML or AI engineer, they would specifically differentiate what it means.
At a risk of a sidebar, one of the things that's most fascinating to me about the rise of the natural language models was that a lot of the Gen AI we see today, it comes from, like you said, that Google Translate and that effect of trying to translate and really they were trying to figure out how to go from like Spanish to English. And there's this like all this magic kind of capability falls out of this attention and almost is like half the translation system. Because I think in the original translation systems, they had to take in text, they got to figure out what it means, and then they got to spit out text. And I don't think they had any intention to make kind of the modern ChatGPT systems they have today. The intention was to translate. And it's just amazing to me how all of this kind of goes back to this very practical problem. And it kind of speaks to how that's just the nature of research. Sometimes you don't know where things will take you. And the kind of derivative industry that's come out of this is unimaginable. But I'm sure you were living it more than I. I'm just discovering it from the past, looking forward.
This is very, very interesting thought. Actually, it got me to a very different place here because you mentioned about language translation. We don't think about it, but languages are very, very important. Human language is a very, very important thing in human evolution because this is how you communicate knowledge. This is how all the work is done, and there is lots of wisdom hidden in languages. So the attention that when they did it for translation, what it unlocked the underlying meaning and context on those translation, and that's what became ChatGPT and everything. So even though it was not intended, but it actually happened because that's the really attribute of language itself, which came fully open. And we have all used this word large language model. So that large is actually very meaningful because the context, it became entire internet level data as a context. And that's why it gets so much more meaning out of it. That's why so much more happens in this Gen AI world with the LLMs, right? And Gen AI is bigger because it's not just dependent on language, but the same concept then gets applied to other meaningful contexts. So with VLM, which is visual language models, think about context. Like if there is a picture of three of us and this logo and stuff, there is a context that, and it could be a language plus human, that there are three people. They are sitting in a podcast because they are all sitting in front of this kind of microphone, right? So there is a context. It comes from picture. Similar context happens from books, because if you read the first paragraph of the book and then you go a few pages later and you read something, which is not mentioned, but you now have a context. What you started reading, it's going to be related. Same thing, it keeps on going and going and going, right? So that whole idea of attention is context within something that is more related, right?
You made me think, is it going to still be true that a picture is worth 1,000 words in the future?
It's probably worth more than 1,000
It might
words
be worth more.
if you give it to ChatGPT.
Yeah.
But and this is maybe like a basic, or maybe sounds like a silly question, but out of just my curiosity, because people used to talk about like semantic models and like how that was going to really be what changes, the game when it comes to like what we're doing today with ChatGPT. Like how are semantics being, like how is that different?
Like I don't differentiate.
Yeah.
So I think we have to take some context, right? Like if somebody's saying semantic, it's going to be different in what context they are talking about, right? So I think that's going to be more important. So because to me, semantics is still a language, unless I'm unaware of where this thing is going. But I think it's all. So I think maybe in terms, because I do on the coding side of the coding models people are talking about, I think that's one way of looking at it. So even in coding, like languages, when people are using languages to create programs or still using create program, there is a meaning to it, right? There are certain instructions to it. And then this LLMs now with the coding emphasis. So general LLMs are also doing coding, and there are specific coding models as well. So they have very good semantic understanding, right? Because there is a structure to a programming language. And so what Gen AI or LM unlocked is translate that instruction into programming, and then ability to recreate that, the gen part, the generative part. So first is understanding part in the Gen AI, and second thing is generation part, right? So you're actually using that. So in terms of coding models, if you look at it, the semantic means how you're going to translate that whole thing together. So I think that's unlocking your existing knowledge of how languages were built or how certain knowledge base has been created, and now use that semantic to bring meaning out of it, where model itself is not doing anything. It's just translating into the instruction set that is given. And then you are actually, and that's where the agentic work, most of the agentic work comes out into being, right? Because what your model is doing, it's creating that code of how this agent is going to run, and then you get the meaning out of it.
So I guess to bring it back to energy and in the application layer, we're seeing a lot of innovation. I think with the like agentic AI coming out of the Valley, coming to programming and coding, and I did a little world tour of like looking at how people are doing implementing AI within energy, and I think one of them is like here at Collide. They're putting workflows together for the energy industry. The only other applications I'm starting to see are around helping people with like carbon accounting or just accounting in general. And I'm curious if you've seen interesting applications for these new VLLMs that are pushing the envelope here for the energy industry.
So when you say VLLM
or regular LLMs too. Yeah. I think I know you previously worked on a VLLM. So
because VLLM and VLM is two different terminologies, which are both valid. So VLLM is more how you it's like virtualizing the LLM, and it's much more related to inference, which everybody is using for cost and how you're gonna run efficiently and everything. And VLM is the vision language model.
Oh, okay. I think I misheard you. Okay. Yeah.
So it happens actually. It is not the first time I'm having this conversation, and it's easy to miss, right? It's very close terminologies. But I think VLM is an important thing. But before I go in VLM, actually, we should talk about there's something called CNN.
Okay.
The CNN is an older thing.
Okay.
So all the computer vision previously, and even now, lots of it is based on CNN.
Okay.
Even when you are using your facial recognition to open your phone. All of this is on the CNN, which is convolutional neural networks, because it uses convolution layer to get your features and everything.
Is that like the math problem of convolution? Is that where that comes from or something else?
So there are convolution layers. There is math and lots of math and geometry and everything is involved in it. So you basically you for an image, you're finding basic features out of it. And those features are then that next translated into some meaning and then higher level object. And that's how most of the computer vision is getting trained. And that's where you don't create your own computer vision model from scratch. You always pick something which is the closest and then put your own data and then get the next level of meaning, right? So basically initial could be your lines and edges and all of those things and color detection. Most of that, it's not color detection, but edges and blur and all that stuff. And then eventually you create objects. And simple examples could be, okay, you can start identifying cats. Next level, you say, I don't care about just cats. I really want to see if it's a tiger or a lion or a house cat or something else. And then you can go further and further but you have to have data. So with that context set, what VLM did, now you can take that data, all that information, and that got trained into your language models. So now you mixed your vision with your language meaning. And when the language model got trained, you could have done a straight image and you can label it with some language that, hey, this is cat and this is not, and that it will get trained, which happened initially, and it still happens in lots of things because not everything is gotten to a finer detail. But you were able to get like much more deeper meaning because if you had that underlying convolutional layer data to train with it. So that actually really helps. So what it unlocks now real meaning with pictures. And you can actually do lots of real world, physical world work. So you can actually do scene analysis, which typically as a CNN model, you have to specifically train for that particular scene. Here now, because it can mix and match just like large language model from lots of data. So it can do those sophisticated things. Even vision language model comes in different flavors. There are like image vision and there are native video vision. Most of the image vision could do your video as well because each video is frame of images. But if you have to do all of that at that level, then you're doing more introducing more processing, and it becomes more complex. So lots of this limitation on VLM right now, even though it unlocks, is on the size of data and size of model and processing and everything. So there are lots of optimization happening, lots of people, and this is one of areas of interest for me. That I really explore a whole lot is how do you stack different models? So because people, on one hand, everybody's trying to go for this one model which does everything, but I think people are realizing sooner or later you get into limitations. So sometimes you may just get into different meanings, a very good model which picks up a picture and a person and this, and then you take that and give that to the VLM as a further data, just like your prompt. You're adding more things to your prompt. You're adding more pictures and more knowledge to your VLM. And I think you'll get much better output from that VLM.
And so again, another basic question, but like all these models that, we use, like where do you who's creating these models? Where do you get them from?
Yeah. And why do they do it for free?
Yeah. So lots of this is happening in the research area. And then companies are also realizing that they need to so think about your Linux, like, hey, why anybody created open source Linux? And yet industry benefits, there is commercial application. I think same thing is happening on model world as well. And the example I gave was CNN, where people are building on top of each other's. That's actually a very good value proposition for us as a whole world, that if it's more open source, more data is available, especially on the basic foundational level, then more people can build on top of it. And if they publish it back, then the community benefits, and then you got the next level of enhancements on it.
So anyone can build a model?
Anyone, but typically researchers are building in universities, but anyone can. I have built some, but for a vision language, a large language model, it's very, very resource intensive. So individuals are not. That's where all this foundational model investments are going in, where everything is happening. But there are efforts to simplify that. So like Meera Murati, from the former CTO of OpenAI, who started this company called Thinking Machine, they just released a product called Tinker, which allows you to fine-tune LLMs currently for researchers, and they take care of all the complexity of training, right? So we are going in that direction. On a not even an individual level, but still, there are lots of small language models where individuals can tweak, then the terminology is called fine tuning. So people can put their own data on top of SLM. So if you have proprietary data and you don't want to really you give it, let's say it's medical data, right? There are regulatory requirements, or there are other compliance requirements, or another proprietary data, which is very good, and you want to use that. There are multiple ways to do it. One is to do fine tuning, right? So Unsloth is one of the libraries people use to fine tune those small language models. It's still resource intensive, but and a smaller organization can do that, right? Mm-hmm. And even individuals with some resources can do that. So that's a possibility. Should you do that? I think that's another question.
And when we think about AI, tech companies, tech startups in general, we think about the Bay Area. That's where a lot of the development happens, and a lot of the learnings come from, because there's such a huge concentration of computer scientists, engineers in that area. How have you find kind of operating as an AI expert in Houston? Like, what do you think is our level of maturity when it comes to AI as a city?
I would actually say that we are not too far behind. And the reason is Houston's thriving energy industry do put lots of effort in cutting edge technology. The problem we have in energy industry that we work on physical thing, large infrastructure thing on the industrial side, and they last too many years. So if you're going to look from the lens of what you see out there, energy industry is done, you will not see the results compared to Bay Area, which has lots of consumer heavy, where the results are immediate. So same level of technological work may be happening. And I did mention to you, 2005 in energy process industry, we were working on this swarm intelligence model, right? And I'm sure many other energy companies were doing that. They adopted ML and everything very early. The thing is, their results don't show up as fast. Doesn't mean that work is not happening. So just wanted to do that. And maybe that's the reason people may concentrate toward Bay Area, but that doesn't mean that a whole lot is not happening. So there is a whole lot of positive in Houston, which shows up a little bit later in public domain.
Yeah. I feel like another thing that happens here in Houston, and I don't know if it's cultural, but a lot of companies that are large try to keep that know-how in-house, and probably because the control of data is so tightly coupled with the technical expertise. And I think a classic example would be just image processing around subsurface data. You don't necessarily want to, like if you're an oil company, you don't want to put that out there, and you kind of want to have that competency to know what it means in-house. And so they have the resources to build it inside if they feel it's valuable. And that never becomes a startup, basically.
Yep, that's true.
Yeah.
And and I know there's a lot of talk about so far a lot of the AI progress has been in the digital sphere, right? Like now when you're talking about Houston and you're talking about industries, it's really the physical sphere and how you're really bringing, the digital part of it, like you're bringing the vision, the cameras and a 3D, how are you seeing it actually in action from 10, 20 years ago when you were in industry to what have you seen some real examples of it being applied?
Yeah. So I have a very good example. I was talking to this one solar financier. He was mentioning that whenever they put investment or finance a solar project, and especially on the residential projects or even commercial projects, small commercial projects, one of the things they want to look for, and they're looking for the solution is, and this is like a few years back, 2-3 years ago, is there are trees around your solar.
Mm-hmm.
Now, you can take satellite images, you can take drone footage before you actually finance that project of the property. With computer vision, detect what kind of trees they are, what are their maturity, in certain number of years, how much they grow, will they impact the sunlight to the solar, and based on that, they can actually calculate the ROI of the project. And that's like a very important, very, very practical energy use case for solar use of AI in physical world.
Mm. Yeah, and I guess it's like also robotics, right? All manufacturing now is like just really advanced robotics, and a lot of it is AI.
Yeah, so that's what's going forward. Looks like. So going forward is the whole idea of physical AI with robotics in industrial space, and we have this company Persona AI in Houston building humanoid.
Talk to us about them. Actually, we should bring them on our podcast.
Is this Nick's company?
Yeah, Nick's company.
Yeah.
So they are building humanoid industrial robots, and they're building in Houston because we have all this industrial infrastructure who needs it.
Are you ready to lead the decarbonization charge? EnergyTech Nexus is your platform for growth, offering unique resources and expertise for energy and carbon tech founders. Join us at energytechnexus.com and start building your Thunder Lizard. I am looking for that time when I can get my personal AI maid who can clean after me, do the dishes, all of that stuff.
Yeah, so there are lots of companies working on humanoid robots, and that's where Nick wanted to differentiate, and that's the Houston advantage, right? Mm-hmm. Like there are lots of industrial use for humanoid robots, and why that, and why not just build some automation? Mm-hmm. Because there are lots of industrial tasks that are very, very specific to your like which require human intelligence, but they are small tasks. Like you don't want to do tooling and machining for it, and that's where you need humanoid robots to switch from one task to another task, or a combination of tasks to accomplish something.
Why are they called humanoid robots?
Because they function like human. You will have the hand and everything. And
they look like humans. They're like made to replicate.
So it's not just more like human. It's more how they're functioning like human as well.
Like having a hand
and then
feet.
picking up a small tool, or
Dexterity.
Using a tool to do another thing, right? So lots of these things comes from like human physiology, how human physiology works. So same way, and then you can actually train on human action. That's another good part about that, right? Because you can see how humans are working, use that as a training data. Another use of computer vision on the reverse, where you're generating training data to train for robots to work in a certain way. And then they are using computer vision to actually recognizing and doing that work.
Is that a lot enabled because like just the computation is there today where it's practical? Or what's changed in the last few years?
Yeah, so computation definitely is one big thing, and if you have to go back, I think within industrial IoT that enabled lots of things happening in there. So this is like next level evolution of that. Because why did IoT happen? IoT happened because we were able to miniaturize processing, and we were able to put communication on those miniaturized stuff. To create IoT devices. But most of the IoT industrial Houston we were talking about, it was doing it for a long time. It used to call industrial IoT. And that's where I was working for many, many years, part of all of these farm intelligence for using all our IoT data. Same thing happening in AI side. Now you have processing, which is much bigger on the edge. So that edge processing is what's enabling things to happen at the away from data centers, right? Otherwise, if you think of AI LLM, everybody's thinking of large data centers. You can't put large data center on the robot, but you can do edge processing, and there are processors that are coming up. They are already there in the market. Like NVIDIA has this whole Jetson, which is an edge thing, and they're building a whole line of other processors for edge computing, and those edge computing devices like robotics is one very good use case or growth use case for NVIDIA as well.
And that's where in long term, like the difference between like large language models or large AI models and using those to scale down and train smaller models like becomes valuable because you're really trying to push things more to the edge.
Yep,
right.
That's true. And then also the thing I talked about is like you are going to have a stack of models, right? So you don't need to process everything together. You process what you need at that moment, and then also you have communication. So you can anything that is larger and you still need to process, you can give it back to your cloud data center and then just get the input. So depending on how you're gonna design it based on your need, but idea is to have it independent of cloud most of the time, but you don't have to. If you are working in a warehouse, you have communication, you have cloud processing, you can do cloud processing, but your near real-time actions need to happen on the device itself.
As an AI expert, are you ever worried about AI going rogue on us?
No, never. I do believe that people will misuse it, which has happened with any technology. But AI on its own going rogue on us is going to be still a human action. It's not going to be AI action.
Yeah. So I have a related but different question. I've learned that in programming you have these things called like unit tests where you like make sure if an input comes in, like the right output comes out. And that works when the technology like is not statistical, right? Like you have a very expected outcome. Is there a unit test for like these modern AI models, or how do people think about that? Like, how do I know what's going in is generating what I want to generate out? Yeah.
You're right, because this is all probabilistic, right? So it's not deterministic, but there are ways to make it deterministic, right? And there are many techniques. So one of the techniques people use is like using two different smarter model and not so smarter model, and then take output and evaluate from the other, and then give a yes/no output on the first one, and that becomes your unit test, right? So the model
like a validation
model.
Okay.
Right? So output and then say, is it a good thing or not? And that's how it's still probabilistic, but you're changing in a way into a deterministic.
Mm-hmm. Interesting. So that's how you keep it from going rogue. You got to make sure you validate.
So as you're working with startups, like what kind of advice or what kind of issues they're coming to you for that they need help with, or like maybe something that they like fundamentally get wrong often that you see with startups?
So I think it's variety of issues. One is it depends on who's coming, right? So if some founder is not technical, doesn't understand AI, and they use this buzzword, I think about a year and a half until about a year ago or so, I used to hear a whole lot, I want to train my own LLM. I'm like, do you have $75 million? That was the cost estimated at that time of Meta doing its training. And then, so demystifying that, like clearing that up that, hey, do you really need to? You're not, right? Do you need to use? Are you applied AI? So that was very basic. And then the people who knew that, and then they say, hey, I want to fine tune versus RAG. So they don't get that clarity. But overall, in the whole thing picture, everybody got wrong a whole lot more, even though they knew, is they don't have enough proprietary data to work with. So the thing is, they think they have something unique. It's not unique unless you have your own unique data to it, or you have a very unique way of looking at it. So data was one of the biggest thing that comes in, because either there's not enough data to process with, or if they have data, the use case is not big enough for you to provide. So they will say, hey, I need to fine tune this, but it's not cost effective for them to do that, right? Maybe a RAG is a good solution. And there's other side as well. There's somewhere where people say that, so let's say if you have a large amount of data, which is not changing, and you do a whole lot of inference on it, a fine tuning on a SLM may be a better way of looking at it versus doing a RAG, because RAG gets you started much faster. But the cost is higher. But if you're not doing lots of inference, then it's very good. And typically that's what's happening. Most of the use cases are like that. So I think data and how to process it, I think many people go wrong. And then some people just they don't know if it's applied AI or is there a solution they can use. They just want to have their own AI component where they can just build versus buy decision they go get wrong. They do not unlock the real value of their business. They may have it. It may not be in building their AI, but actually applying somebody else's AI in their business.
So how do you think we should be thinking in the future about AI and like how it can be applied and impact the way that we're working?
So not just founder, I'll give it for all the human beings, whoever is interacting with AI. I think people, and I'm going to inject the AGI discussion in it as part of this answer is, we talked about this whole language and meaning and context in LLM training, right? This is all rational intelligence. And AI is getting very, very good at it. It's getting better and better. It's getting better than humans, much, much, much faster. And it will keep on growing. It will keep on happening for a long time. You won't be able to compete as a human on the rational intelligence level. But as a human, our intelligence have more planes. We have this emotional intelligence plane. We have a spiritual intelligence plane. And I'm not talking about the religion part. I'm talking about your gut, your feeling, everybody who has this internal thing, right? Your rational intelligence within AI is mainly dealing with your existing knowledge that has been fed into it. It is allowing you to discover new knowledge. It is allowing you to combine existing knowledge to present in a different ways, but it will never create new knowledge because human new knowledge comes from the combination of these additional planes of intelligence that we have. If we understand that, master that, and many people do, and has been happening for centuries, and it's keep on growing. That's how we, a human race, we are growing in our intelligence and our capabilities. We will be able to unlock with AI and actually become its master and have it serve us than other way around. And I think that's what I would want everybody to understand. So as a founder as well, same thing, that your human intelligence is much, much higher than AI. Yes, use it for rational and it's going to get better. Just like from, and I give this example of you were in agriculture age as human beings, and then suddenly industrialization started happening, machines came in, agriculture didn't went away, human race didn't went away. We just moved into different kind of tasks. There is no way human power can match what industrial equipment can do. We've way surpassed. Same thing will happen here, and we will unlock our next level of plane. That's where we unlocked informational technology wave within the human thing, which is your current wave, what everybody's doing and everybody's worried about. So if you look through this lens, you will unlock lots of new possibilities for innovation, but also how you're going to use AI for your own good and humanity's good. So that's the lens I actually try to give it to anybody who's asking, the founder or any person who is worried about AI.
Yeah. So anyone on our team knows when I think a lot, it's when I sit in the shower, I have like downtime, and it's like I enjoy, like it's like a sauna experience for me. But it's like I started to like disassociate, right? And I'm just thinking about different things, and that's when the
Ideas.
like the eureka moments kind of play against each other. And it's like half of them don't make any sense, right? It's just the brain just trying to like work out connections that maybe aren't there. But it's kind of the irrational ideas emerge, and that's where I get my best ideas. Is literally just taking a shower.
No, yeah,
it's a chance to process things that aren't rational necessarily.
Yep. So that's exactly what is spiritual intelligence, and there was like about 20 plus years ago, I read this book from Dana Zohar called Spiritual Intelligence. Just like we have IQ and EQ, she defined it as SQ. And that's exactly those eureka moments, the things that you what you call gut, intuition, all of these things, where it's coming from, right?
You get a download.
But there's very little data that
Yeah.
justifies it. It's just like a feeling.
But
right?
think about this way, that we say we don't know why it happened, how it's happening, right? Talk about any human knowledge today. Earth being round, and I don't want flat earth people coming here in the discussion. That knowledge, it was a fact, existed. It's a universal knowledge. It came in human consciousness when somebody thought, and eventually somebody observed, right?
Yeah.
So same thing is happening in just this thought process of Eureka and stuff. We don't understand as a human what is happening internally. That itself is a huge opportunity for research and figuring things out. We have this whole new human, like neuroscience itself is a huge area for. So many people are worried jobs are going away. Yes, you will have to retrain to look for new things. I cannot tell what tomorrow is gonna be, but by just the way industrialization reduced the need for labor for the output, same way the AI will reduce the need for labor for all the information jobs. So it will unlock something. I don't know what it is going to be. I think it's our human ingenuity which is going to play out and will unlock that.
And that's like, it plays to creativity, right? Like that's what they say when you're wandering, when you're going for a walk. Like for me, it was a lot like when I was in Norway, I would be sitting on the bus is when like random ideas would like stick together. And then you're like, you have this like, oh my God, this is the solution. I need to do this. And that's what, so when I'm thinking about like the next generation who's going to school or like people early in their career, like what kind of skills should they be focusing on to be set up for this world where you don't need to like learn all the formulas. You don't need that rationality as much. How are you going to solve problems?
Just like calculator, you use calculator and you don't have to, you're solving bigger problems, right? And you're still using calculator. Same way you use your rational intelligence provided by AI. But think about it, even then, you have to provide new knowledge for that to grow, the AI to grow. AI is not going to grow without humans. It's not going to progress further. Yeah, it may codify everything we know as of today. Let's say if all the processing power is given to AI, it can codify everything. Right now, it has not even codified that. And I think earlier part, we talked about languages, right? Even there are things across languages the AI will not understand because there are meanings to it that are much deeper in a one cultural context, which are not codified. They're not written. There are many oral cultures exist in this world. Even from the community I come in, it's very oral. There is this entire oral history of my forefathers, which everybody talks about. It talks between the cousin. And we ask anybody, did you ever write it? No, nobody wrote it. Okay, AI doesn't know that information. But it's also the wisdom that built from that. The human wisdom is not come in there, right? But even if that get codified today, everything, still it's existing experience. Any new experience, still we are the humans who are going to feed into AI, right?
Yeah. One of the things that happened last night that was interesting is we were just chatting. We had a little team dinner. And I think at some point, like 5 different languages got whipped out. Yeah. And like 4 of them were from across like the Indian subcontinent. And I think there was a question of how much did different people understand. Because like in many ways, like between Urdu and Hindi and was it Punjabi you were saying, like there's like a lot of loan words, but they just mean different things. But that was fun. I don't know what we're going to do with that information, but it reminded me when I was touring through Asia, there's a very significant concern about like losing the language context as a form of history. Because in some ways, because a lot of the language models are getting built on English. English is our lingua franca today, I guess. And a lot of the models get built that way. You aren't necessarily, yes, you can translate, but they're not necessarily being trained on like localized knowledge and localized semantics. And so I think what we were talking about specifically, India, like the words just mean different things in different regions. And that might be hyper-local. And so when I was in Singapore, there was a lot of interest in saying, well, we need to capture Singlish and make sure we have a version of this that is Singlish. And both so we can process like everything locally because they're worried about data sovereignty, but also just being able to preserve that kind of history. And I think one of the other participants around the table was talking about preserving Taiwanese, which is a tonal language, and the pinyin doesn't necessarily like capture the 9 different tones. And so it was a interesting conversation about there is a lot that hasn't yet made it into the little written translation that we're seeing for the large language models. So there's a lot of opportunity still.
Yeah. So I can bring in this whole thing back to climate tech. Actually.
Okay, good. We can do that.
Yeah,
Perfect.
because I think we're going up, but within the same context, right? The thing is, industrialization allowed us lots of facilities, but it also created lots of problem, including some of the climate tech problems. Humans were dealing with lots of these problems before industrialization of heat and how to keep cool and with lower things. Now, there are like architectural things in different parts of worlds that have been built to do cooling and stuff, right? Which are very, very sustainable. All of this coming of knowledge from different cultures and languages needs to be preserved and understood, because that's where you can get new innovations. Because maybe, and it could be again the combination, like AI may be good at combination, but if you don't feed that data, it's not gonna get you there, right? So coming from like what you learned in US and what in sub-Saharan Africa, mix the problem together, and it may be preserved in these different languages and cultural context that can come together, and you may solve a climate tech problem in a very different way than the way you're thinking from today's sciences.
Yeah, no, that's great. And it's, especially with energy, it's a global industry. Climate's a global challenge. And there are a lot of solutions that are kind of hidden out there that aren't necessarily just here in Houston, Texas. And so that's something we're going to be working on.
And what are you excited about, what you're seeing in Houston, when the startups come up to you, what they're building, what's your sense of like what's coming for us in the next couple of years?
Yeah, so I think one thing is internet has done that and AI has accelerated it. Is I think what's happening in Houston versus happening somewhere else is not very different now. So very interesting things are happening. Like a travel tech company is like a completely consumer company would be coming out of Houston, right? We just talked about humanoid robotics coming out of Houston. There are fintech solutions coming out of Houston. So there are way many things coming out of Houston which are beyond energy we are known for. But I'm going to talk about the most important part, which many people like. We have like 4 big things in Houston: energy, health tech, space, and logistics. And a 5th bigger thing which people don't realize is Houston has a very large, small to medium size business economy, which is very diversified. And as we talked about different ideas coming together, and that's actually starting to happen in Houston, right? So we are actually learning from each other's industries, solutions, and that's actually advantage in Houston.
Interesting.
To bring it together, right? Because, and I can give you one simple example, and I think it's one of your prior podcast person. I listened to, who talked about vision tech on safety of worker safety, right? Yeah. And it comes from vision model on human action, right? We do have like lots of retailers and stuff. They do theft detection with computer vision, right? Now it's also based on human action. And now 2 different industries, same solution come together, and you will have a very good solution for Houston, right? Mm-hmm. So to me, I think I see that happening slowly, where people are learning from one industry and applying another. If we can enable that, and especially for folks like you can make that happen, I think we'll see an accelerated new innovation coming out of Houston, which is net new for Houston in its own strengths of industries, but also learning from each other and bringing something completely new.
Interesting. Yeah.
How can people get in touch with you? You're usually you're located at the Ion, in Houston.
So, I have office out of Ion, and you can reach me at on my website AICTO.services. And you can always connect with me in LinkedIn as well and send me a message there.
Good.
Awesome.
Yeah, thanks for joining us.
Thank you for being with us
Thank
today.
you for having me. It was very enjoyable talking.